Alright, time for DraftPhysics.com, debatephysics.com also, but it's always stated there's just no debate. There's no real argument, going through all the testing of a theory or an idea, and all of the crap that brings up. And they do physics does a little tiny bit of that. Just, 25 times the fuel to go 5 times as fast. I mean, they assert things that are just absolutely insipidly implausible, and with complete confidence. Most proven theory in the history of mankind. They've proven that it's 25 times the fuel to go 5 times faster. They proved it. Well, of course, they didn't prove any of it. They can't even draw a two-slit experiment pattern correctly. They can't show what the actual facts. They just make up crap about detector experiments. This guy actually has said that banging electrons against a hunk of nickel, a flat piece of nickel, is exactly the same as two slits. I mean, ridiculous physics, ridiculous science. And so this will take probably 10 parts. I'm going to play this series he did on atoms because it's just so bad. Now, I might have played some of this in the past, but the more you listen to it, the more it's just every single sentence is hyperbole, hyperbolic. It's just exaggeration, exaggeration, exaggeration. It's not science. They should just say, this is our personal religion. We would like you to believe our personal religion. Okay, they ought to just sell it for what it is. It's a flat earth theory, frankly. It's so bad. But anyway, let's play the video. And I tried to see if there was some way I could get rid of the stupid background crap. So they play this stupid fucking droning music on and on and on. And at some points it's louder than he is, and so you can't tell quite what he's saying, which is really frickin' irritating. Scientists got to put on a show, because it's really not about science. It's about the show for the religion. So this is just like making storybooks for children, about God and, Moses or something, It's crap. It's not fucking what scientists should be doing with their time. Making these show videos that don't have anything to do with really the truth. They're such glosses. They're such whitewashes of the actual truth. All right, play the video. So I cut the introduction. There's just 3 minutes of, 36. It seems like 3 minutes, 36 seconds of annoying fucking goddamn bullshit. This. Fuck you. Waste my neurons. Just waste them right in front of me. Just say, I'm going to waste a bunch of your neurons. That's what a good scientist does, is waste your fucking time. I mean, I might waste your time now and then with saying something like this about wasting your time. But it's completely accidental. It's not on purpose. This is on purpose.
This is the story of the greatest scientific discovery ever. The discovery that...
So everything is the greatest, the greatest discovery, and then was another greatest, and then the next greatest, and it was all greatest. And it's just, please, just shut up with this crap and get to your argument. Get to your, this is why you should believe in the Holy Ghost. Get to that part. But he never gets to that part.
Everything is made of atoms.
Everything is made out of electrons and protons. That's what the scientists should have figured out. The only real universe is electrons and protons. That's all there are. Charges. And the charges interact. I have a perfect simulation of that. I don't know if I really should. I'll break in and show that. I'll do that. All right, there it is. Quickly. This is what the universe is really doing. It's just electrons and protons, okay? And they interact based on this inverse property they have. So there's two kinds of force. Maybe you can see that, red and green. And there's two kinds of matter bit, red and green. And so it's electron force and proton force, and electrons and protons. And if you just inverse their reaction to the two forces, and 3 interactions possible, absorption, reflection, and changing the force identity, it works fine. It works perfect. Electrons, protons behave exactly as charges should, with those simple rules. That's the real universe right there. That's the real stuff. There's nothing else realer than that. Okay? Whatever they do first, then this stuff does it later. That did it first. This was electrons and protons interacting. It was not me. Okay. I did it, of course. Okay, the thing called me did this. All right, but it had to happen because electrons and protons were in a circumstance where they had an arrangement that forced it to happen. Okay, something like that. I suppose I could leave that there. Let's see how distracting it is. Yeah, after I make the video, I'll see how distracting it is. Whatever. You'll deal with it.
Vast variety and richness of everything we see around us in the world and beyond, how it's built up, how it all fits together, is all down to atoms and the mysterious laws they obey.
All right, so it really isn't down to atoms. It's down to electrons and protons. And everybody already knows, I think you all know that, right? That the atom, you can bang into the electron on the outside of the atom and you can have an interaction and it doesn't really disturb the rest of the atom. And, it's the electrons and protons. And the electrons are on the outside and they do most of the action with the rest of the universe. Blah, 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 blah.
As scientists delve deep into the atom, into the very heart of matter, they unravel nature's most shocking secrets.
Okay, so they didn't unravel anything and they didn't do anything logical. And it seems like every chance they had to go with something rational as a theory, they said, well, don't you have any irrational choices? I mean, don't you have the flat earth choice? Don't you have the preposterously silly choice? Because that's what people want, is some kind of silly explanation for reality rather than some mechanical one. Apparently. And the physicists are just as bad as the religious kooks. They want wooey nonsense. They think it's fun to be ridiculous.
They had to abandon everything they believed in and create...
So nothing had to be. Nothing had to be abandoned, okay? You didn't have to abandon reason and logic. You didn't have to believe, oh, it really takes 25 times the fuel to go 5 times as fast? It takes 25 times more work to spin something 5 times as fast? When I, drill a hole or something and I go 5 or 10 or 15 times faster, I'm using 100 times more energy? No, not.
A whole new science. A science that today...
A religion. So it's a religion. They're just storytelling. There's so little hard evidence for a single thing they assert. And if you really investigate the evidence, you can see where it can be interpreted in 600 different ways.
Underpins the whole of physics, chemistry, biology, and maybe even life itself.
Oh, blah, 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 blah. And this is all just to create woo. They just want to say determinism isn't real, that we're all spontaneous little flowers, and we're spontaneously doing fun stuff because we're fun. Oh, fuck.
But for me, the story of how humanity solved the mystery of the atom is both inspiring and remarkable.
What's remarkable is so there's 3 videos in this series, and there's no continuity between them, really. And he just keeps he basically tells the same story a little different. The characters are a little, Rutherford's this way here, and then he's this way in the next one, and he's that way in the next one. It's never quite the same story.
It's a story of great geniuses, of men and women driven...
Preposterous nonsense. Again, just, Dirac comes up with this idiotic equation that predicts something as stupid as antimatter, which there's no evidence such a thing could happen, that you could reverse the role of the electrons and protons, because guess what? Photons only affect electrons. Just a fact. So if you have the electrons on the outside of antimatter, a photon can't interact with antimatter. It's a completely different ballgame. It's going to react with the nucleus and cause all kinds of who knows what.
By their thirst for knowledge and glory.
It's just silly.
It's a story of false stuff.
It's a story of 100 assholes, okay, who are all a bunch of, nerdy agenda people with all kinds of bigger picture philosophies, telling everybody else what we should all believe. And because you're all too stupid to do any research and really look at how they're drawing their conclusions, it's obviously they're just doing the silly fish story. They're just making this Jesus character, so now he's going to talk about the atom and he's going to just describe a Jesus. He's not going to describe an atom.
Arts and conflicts of ambition and revelation. A story that
that's what it is, revelation. They all had some sort of, I can imagine, but they never test it hard. So yeah, I can imagine that light is bent twice as much by gravity. Too bad they can't really prove it with an actual experiment. And the Eddington experiment is just perfect hyperbole. in the sense that it's just this insanely exaggerated piece of scientific history. It's actually an example of all the crimes you commit as a scientist, in the sense that the guy admits he got 10% of the data quality. He admits in his own journal, I wouldn't stake my life on these results. And what did they pervert that into? A New York Times headline saying Einstein proven right. I mean, that's obviously not good science. Anybody who says that's good science has got to be a lying piece of shit, or, it's obviously the definition of bad science.
Leads us through some of the most exciting and exhilarating.
So this is about excitement, exhilaration. No, it's just solving a puzzle. You have certain little pieces of evidence and you want to put them together and explain the theory, right? So Darwin came up with a really nice explanation. No woo, no quantum, no bullshit. And you people instead in physics just are serving up people this completely all kinds of Holy Ghost all over the place. Just make up invisible men, invisible characters, angels. You might as well just call them angels.
Rating ideas ever conceived of by the human race.
Oh, brother. I mean, just ever conceived of. It's like we can't tell. No, oatmeal's quantum oatmeal now. Yeah, fuck this. Just so bad.
And for a working physicist like me, it's the most important story there is.
Well, whatever. The biggest lie ever told. Okay, that's what it should be called. All right, I gotta get rid of the commercial. All right, yeah, get rid of the commercial. I have to switch the thing. So anyway, no more simulation.
On the 5th of October 1906, in a hotel room near Trieste, a German scientist called Ludwig Boltzmann hanged himself.
So I don't know why they make an issue out of this, right? I mean, he had problems his whole life. This is, to blame this on physics or something, or somehow it has something to do with the physics, it's just such bullshit. He'd gotten himself married, he had kids, he had all kinds of troubles. So it's not about physics. It's about his, it's about some other problem,
Boltzmann had a long history of psychological problems, and one of the key factors in his depression was that he'd been vilified, even ostracized, for believing something that today we take for granted. He believed that matter cannot be infinitely divisible into ever smaller pieces. Instead, he argued that ultimately everything is made of basic building blocks, atoms.
All right, it's clearly not a dramatic thing. He's making this all out to be something like all the physicists didn't believe in atoms or something. And, it's just kind of bullshit. Obviously, it was an open question. It was discussed all the way back at Newton's time. I mean, they already knew about this idea that, of picking something apart, and they knew that they could make a pure element, that they could purify something so it was just one kind of stuff. And they, surmised the obvious, that it must be all made out of these little tiny things that are this. Well, anyway, it's just bullshit. So again, more exaggeration. Continuing.
It seems incredible now that Boltzmann's revelation was so controversial. But 100 years ago, arguing atoms were real was considered by most to be a waste of time.
So he says so, right? I mean, he says so. It doesn't, you're going to have to show me evidence that all the physicists on Earth in whatever, the 1900, didn't believe in atoms.
Philosophers since the Greeks had speculated that the world might be made out of some kind of basic unit of matter. They realized that they were far too small to see, even under the most powerful microscope.
Again, they'd already done this stuff. I mean, come on. We were already mining ores out of the ground and finding the little tiny pieces of the stuff and, melting it down. All this stuff was already being done. So the idea that this stuff is elemental, that there are, only a limited number of the configurations, the core little bits. Come on. This is just, nonsense.
Speculating about them was therefore a complete waste of time. But then, in the middle of the 19th century, whether or not the atom was real was suddenly a question of burning importance. The reason...
You can use the keyboard, might be better. Key importance. All right, let's finish.
Reason was this: steam.
So again, it's going to make something out of this. You know, like I said, they had figured out that the steam is about, you inject heat and then atoms become bigger. They take up more space. The substance takes up more space. With the opposite example of ice, but everything else, it can be quite large amount of space it takes up if you heat it. And, you know, they had already done, you know, the vacuum experiment is really old, you know, where you take the two spheres and you put them together and you suck the air out, or you heat it and then you let it cool and it creates a vacuum. I mean, all of that had been done 100 years ago. So this was not some sort of, oh, gee, what a bold theory. Just wasn't.
By the 1850s, it was changing the world. It powered the mighty engines, the trains, the ships, the factories of the Industrial Revolution. So figuring out how to use it more effectively became a matter of crucial commercial, political, and military significance. Not surprisingly then, it became the key question of 19th century science.
It really, and this is in the same idea though. Rutherford's doing his experiments. I mean, they're, you know, he's got the motor force, so there's all kinds of stuff happening in science in general. And it was becoming, obviously this has to do with money and capitalism and all that kind of stuff. And so sure, there was lots of investments and lots of energy put into the, you know, you could make a fortune, you know, doing physics.
The demand to build more powerful and efficient steam engines in turn created an urgent need to understand and predict the behavior of water and steam at high temperatures and pressures.
It was nothing more than the same rules that apply for anybody making anything. You always want it to be more durable and, you know, to be able to outdo the competition. So there was nothing unique about the steam engine. Everything gets modified by the need to economize.
Ludwig Boltzmann and his scientific allies showed that if you imagine steam is made of millions of tiny rigid spheres, atoms, then you can create some powerful mathematical equations. And those equations are capable of predicting the behavior of steam with incredible accuracy.
No, the more important thing is just to understand it as the idea of you can draw a picture of it. That what you're doing is creating energy between these things hitting each other. So you poke harder and they have more energy as a result, and then they bang into each other with more energy. And, you know, it really shouldn't have been. I mean, clearly they made a huge mistake not realizing a lot sooner than they did that heat was momentum. It was just, you're just moving very small things instead of big things. But it's just momentum. And you transfer momentum. And you can transfer it in one direction and something moves in that direction, or you can transfer it in a bunch of directions and it doesn't go anywhere. But it still has an increase in momentum.
But these same equations plunged Boltzmann and his fellow atomists into controversy. Their enemies argued that since the atoms referred to in their calculations were invisible, they were merely a mathematical convenience rather than real physical objects.
Right. Now, no scientist would do that, right? I mean, they're sort of drawing a picture, and they say, look, here's the picture. You got these little balls, okay? And the fact is you have to conserve their energy. So if you give one of them more energy, it has to spread it to the other ones. And, you know, blowing up a balloon. I mean, come on. It's not that complicated. So I have a hard time believing there was a whole bunch of physicists who found this idea challenging.
To claim that imaginary entities were real seemed presumptuous, even blasphemous. You see,
So all the stuff they talk about, you know, when you think about all this entanglement crap, dark matter, antiparticles, you know, even the other woo stuff like quarks, and they have almost zero evidence. I mean, just nothing to defend it. Neutrinos.
Critics argued that it was sacrilegious to reduce God's miraculous creation down to...
Right, so we know this wasn't what physicists were saying. So again, more bullshit. You know, there wasn't a bunch of physicists. I mean, Bohr was maybe one of those religious kooks, but there weren't a whole bunch of other physicists saying this is the truth, and especially the younger physicists. No chance.
Series of collisions between tiny inanimate spheres. Boltzmann was condemned as an irreligious materialist.
Oh, what a horrible, awful thing to be condemned as. So isn't that the joke? What scientist wouldn't take that as a compliment? Thank you is what they would respond. Thank you. Yes, you properly identified me. Of course, I think your silly fucking God theories are silly. Of course they're silly. Yes, what am I? A materialist? Oh, yeah, that's right. I believe there's a physical universe with materials in it, you know. Yeah, I'm okay with that. So, I mean, what scientist would find that an offensive title? Get real.
Labor Day mattress deals are happening now.
I mean, it's not 1640, okay? It's not Newton's, you know, it's not Newton's world. Newton lived in a world where you had to talk that shit or you got burned at a stake, okay? These guys had no threat of being burned at any stakes. So why the hell would they want to placate a bunch of religious crap? I just don't buy it. It's annoying. I have to reset everything after I pause for the stupid commercial.
Tragic irony of Boltzmann's story is that when he took his own life in 1906, he was unaware that he'd been vindicated. You see, a year before he died, a young scientist had published a paper which undeniably, irrefutably proclaimed the reality of the atom. You might have heard of this young scientist. His name was Albert Einstein.
All right, so it was just deduction, though. Come on, it wasn't like some sort of absolute proof. It was just an explanation for why pollen's bouncing around on the surface of water. Now, the explanation has a flaw in it, in the sense that you could argue that it's only the electrons that are really moving, okay? And that the atoms in the water aren't doing a whole lot of moving. It's just the jiggling is basically their outer electrons are doing all of that action. Because it's not like it was a gas, okay? It's water molecules, and they adhere to each other, and they're stuck to each other, and they're not going to be flying off the surface much. But anyway, we'll just assume that, okay, let's just say it's the atoms that are pushing the pollen. Theoretically, it's the electrons that are pushing the atoms. But anyway, probably a distinction that doesn't matter. So let's continue.
In 1905, the year before Boltzmann's suicide, Albert Einstein was 26 years old. His brash arrogance had upset most of his professors and teachers, and he was barely employable. Then he got his girlfriend pregnant.
Right, so this barely employable part is also this narrative said other ways, because the patent office was very pleased with Einstein. So that's probably another exaggeration. Now, he wasn't employable as a physicist. That's true, but that's the same truth now. There's lots of physicists come out of college, and not too many of them get jobs as teachers.
That was followed by a hasty marriage. He needed a job, any job. Having not quite distinguished himself at university, he took up a job as a patents clerk here in Bern in Switzerland. He'd moved into the small one-bedroom apartment on Kramgasse with his young wife Maleba.
So, in the next video, he'll be talking about the fact that, yeah, they had an illegitimate kid that died, and disappeared anyway, and that's why he got married, and then he had 2 more kids, even though he wasn't at all happily married. All of this bullshit.
Despite dire personal straits, the young Einstein had a burning ambition. He was desperate to make his mark as a physicist. And in 1905, during one miraculous year, the mark he made was truly incredible.
Yeah, it's just sort of ironic that the papers that are less known are the good ones, and the relativity one is just garbage. So, that's just funny that that's the paper. Even E equals mc squared is, mush talk. The matter doesn't have any energy. The only energy it has is the space it occupies, because space is full of energy. And if you occupy space, then you force the energy in the universe to be more intense because you're using some of it.
Having an undemanding job meant that young Einstein had plenty of time on his hands, both at work and here in this tiny apartment, to think deep thoughts. In the space of just a few months, he was to publish several papers that would change science forever. Now, everyone's heard of his theory of relativity, even if they don't understand it, and his paper on the nature of light was to win him the Nobel Prize a few years later. But ironically, it wasn't...
Yeah, and that one was so thin. That's the sad part, is that he said so little that you can't say for sure what exactly he was imagining. But yes, it was the idea that photons are made out of stuff, not made out of woolicles. So that's the important statement.
Either of these 2 papers that had the most impact on the discovery of atoms. The one that made all the difference was a short paper on how tiny grains of pollen danced in water. almost 80 years earlier, in 1827, a Scottish botanist called Robert Brown sprinkled pollen grains in some water and examined it through a microscope.
We're coming up on a major fundraising deadline, and there aren't many more between...
Oh, shut up. Jesus. What qualifies you to be even on my computer screen? Alright, back. Ugh.
What he found was really strange because instead of the pollen grains floating gently in the water, they danced around furiously, almost as though they were alive. Now, while this so-called Brownian motion was strange, scientists soon forgot about it. They found it mundane, even boring.
Well, obviously it'd be really boring if the water was frozen. Yeah, so it's really just showing what heat's doing, you know. And then you can make an argument about the heat is, you know, causing some of the water molecules to actually vaporize, you know, leave the surface. But again, what's causing that is the momentum between the constituent forces that are on the outside of the atom, you could argue, the electrons. Too much movement in the electrons means the atoms aren't going to stick together. But anyway, continuing.
I mean, who cared if the pollen jiggled about in the water? And what had the jiggling to do with atoms anyway? For nearly 80 years, Brown's discovery remained a little-known scientific anomaly. Then, Einstein changed everything. In one staggering insight, Einstein saw that Brownian motion was all about atoms. In fact, he realized that the jiggling of pollen grains in water could settle the raging debate about the reality of atoms forever.
Right, just as the lever proves there's no mv squared, right? So, oh, it's a huge discovery. What a surprise. Nobody could have figured it out. That, yes, there's lots of reasons to know mv squared is nonsense, 1/2 mv squared. It has nothing to do with reality. 25 times the fuel to go 5 times as fast, duh. So Einstein did the same thing. He took something that's quite obvious in a way. Obviously, the pollen grains are getting energy from something. Well, where are they getting energy from? Well, I guess they're getting energy from the water. Well, how is the water jiggling? No. And it becomes kind of obvious that, well, it must be made out of pieces if it can jiggle.
His argument was simple. The pollen will only jiggle if they were being jostled by something else. So Einstein said that the water must be made of tiny atom-like particles, which themselves are jiggling and are continually buffeting the pollen. If there were no atoms, then the pollen would stay still. So Boltzmann and his contemporaries had been rowing furiously about this question for nothing. The answer was there all along. Einstein proved that for Brownian motion to happen, atoms must exist.
So this is not the definition of a proof, right? It's reason to be, you know, saying, yes, that seems like a reasonable explanation, but it certainly didn't prove the existence of atoms, because somebody could make the argument that it wasn't atoms, it was just waves on the surface. There was lots of ways you could get around it and argue against it. It was just one piece of the story, and it was just a piece that fit and confirmed, rather than a piece that was in conflict with the theory. So again, it just isn't the definition of some, oh, well, here, all we need is this piece of evidence and that proves the existence of atoms. Well, bullshit. You need the whole context of all the other crap going on with electricity and all kinds of other things that demonstrated that there must be something in the substance that communicates.
Einstein's paper went way beyond just verbal arguments. With flawless mathematics, he proved that the dance of the pollen revealed the size of the atom. And it's mind-numbingly tiny, 1/10 of a millionth of a millimeter across. A single human hair, itself one of the narrowest things visible to the naked eye.
I would just argue that this, again, not proven, okay? It's a nice statement you can make, but, yeah, it doesn't really... It's just like the Rutherford thing saying that this is how much space there is, empty space inside of an atom, based on the reflection of a helium nucleus, when you could argue the reflection only happens in one location. You have to hit just the right spot to get a reflection back, and if you don't hit that right spot, you hit a little bit on the angle, then both objects end up going forward. You can only get a reflection when you're hitting a heavy enough mass directly enough, and if it's not a direct enough hit, then you're not going to get a reflection.
Is over 1 million atoms wide. Let me put it another way. There are more atoms in a single glass of water than there are glasses of water in all the oceans of the world. It sort of hurts your head just to think about it.
Yes, there's a lot of them. They're very small. but I don't think they've proven how big they are, especially in 1905.
Einstein's paper ended the debate about whether the atom was real or not, and Boltzmann had been totally vindicated. The atom had to be real.
Just saying, it's not about Boltzmann. So there was lots of people arguing, this stuff, and this is just one piece of evidence in a long chain of trying to find enough evidence to draw a conclusion.
By the early years of the 20th century, the atom had arrived. Scientists who'd argued that the atom was real were no longer heretics. In a dramatic sudden reversal, they became the new orthodoxy. But they were to pay a huge price for their success. Before they'd even had a chance to congratulate each other on discovering the atom, it ripped the rug out from under their feet and sent them spiraling into a bizarre and at times terrifying new world.
So this is just all bullshit, frankly. It's bullshit.
And it all kicked off here, in what by 1910 was the world centre for atomic physics, Manchester.
So now we're going to get to Rutherford. And again, these aren't, you're still dissecting. So they already had the electron, okay, by 1910. So, they had part of the story. I'm not doing it. They're doing it.
Two of the most extraordinary men in the history of science worked here in the physics department of Manchester University between 1911 and 1916. They were Ernest Rutherford and Niels Bohr. On the face of it, two very different personalities and the unlikeliest of collaborators. Rutherford was from a remote part of New Zealand and grew up on a farm.
Oh, annoying. Extremely annoying. Anyway, the Rutherford thing is a little bit interesting just because there is actual video, so, of him talking. And, he's a little bit older, but, it is interesting. So anyway, what do I want to do here? I guess I want to pause. Right, back.
Was born in Copenhagen, wealthy and erudite, virtually an aristocrat. Rutherford was the ultimate experimentalist. He loved technology and ingenious arrangements of batteries, coils, magnets, and radioactive.
So, yeah, so far, I have to find some of his papers and read those. Rutherford discovered a lot more than, just this idea of a nucleus. He discovered, frankly, the idea that these neutrons and, deuterons, the idea of you can have a chain of electrons and protons, that to me is the key feature. And how they ever got from Rutherford to the strong force, I just don't understand how they would see the necessity of it.
Rocks, but he was also blessed with a profound intuition. In contrast, Bohr was the ultimate theoretician. To him, science was about deep thought and abstract mathematics. Pen and paper, chalk and blackboard were his tools.
I just don't buy that. I think he's just a religious kook. To woo out the whole universe. He just loved anything wooey, anything to make the universe unpredictable. And why would you want to do that, except to make it room for a god somewhere?
Logic was his path to truth.
No sale.
Although their approaches to their work couldn't have been any more different, they had one thing in common. They were prepared to ditch 3 centuries of scientific convention if it didn't fit what they believed to be true.
So whatever this is, so again, this nonsense story about some ditching thing, blah 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 blah. There was nothing to ditch. It's a perfectly logical. You have to account for it. Once you know there's charge in the universe, you have to account for the existence of the positive and negative components of charge, and it's perfectly logical to identify electrons and protons as being the elemental source of the charge. The thing that's idiotic is not recognizing the existence of the smallest dipole, the neutron.
They were genuine revolutionaries. Rutherford and Bohr were two of the most extraordinary minds ever produced by the human race.
So again, everybody's, all of his friends are all extraordinary minds. It's just, isn't that just too coincidental? Wait till he gets to Feynman. His glorification of Feynman. a guy who couldn't draw an accurate description of any physical object. Amazing.
But it would take every bit of their dogged tenacity and inspirational brilliance to take on the atom.
Frankly, I just don't see any collaboration between the two, so I would argue that Rutherford was a meat and potatoes guy and Bohr was caviar and bullshit.
In 1907, Ernest Rutherford took over the physics department in Manchester. This was a period of momentous scientific change. Just over 10 years earlier, in Germany, came the first demonstration of weird rays that see through flesh to reveal our bones. These rays were so inexplicable, scientists didn't know what to call them, so they were named X-rays.
And really, there wasn't anything miraculous about this discovery in the sense that you could have predicted the existence of it. Once you know light comes in red and blue, then it's not that hard to think of what's below red and what's above blue.
And a couple of years after that, in Cambridge, it was shown that powerful electric currents could produce strange streams of tiny glowing charged particles.
So he says glowing charged particles. No. No, there's no glowing charged particle. So whatever he's saying there is just bullshit.
They were called electrons.
They don't glow. They can cause something else to glow, but they don't glow.
And in 1896 in Paris came the most significant discovery of all. One that more than any other would unlock the secrets of the atom. The metal uranium was shown to emit a strange and powerful energy that was named radioactivity. It seemed straight out of science fiction. Radioactive metals were warm to touch. They could even burn the skin, and the rays could pass through solid matter as if it wasn't there. It truly was a marvel of the modern age. Rutherford was obsessed with radioactivity. All sorts of questions plagued him. How was it made? Why did it come in different forms? How far could it travel through a vacuum or through air? Did it alter the materials that it encountered? In Manchester...
Yeah, so these are all good questions, and it was good that he did experiments to try to dissect all of that.
Together with his assistants Hans Geiger of Geiger counter fame and Ernest Marsden, he devised a series of experiments that would probe the enigma of radioactivity. 1909, Manchester University. These are the props. Gold leaf beaten till it's just a few atoms thick.
So, yeah, whether it's a few, that's really debatable, right? The human hair thing, 1 trillion atoms, he says, so I don't know how, a few atoms? No, I think it's more than a few.
A movable phosphorescent screen that flashed when struck by radioactive rays. And inside this box is the star attraction, a tiny piece of the metal radium. Radium.
So this is basically where they're making the first atom smasher, in the sense that they're taking a substance, the radium, which produces a lot of helium nucleuses moving very fast. So big object moving fast, lots of momentum. So it's the most aggressive form of radiation. All right. And it irradiates a bunch of other stuff, but that's the key ingredient, is you're taking something that's got a lot of energy, and now you're going to bang it into something else and see what it smashes out of it.
Is an extraordinarily powerful source of a kind of radioactivity that Rutherford had named alpha rays. They weren't really rays.
All right, so this was decided because they just shot them out and then put them in a magnetic field and found that some rays go left and some rays go right. So this is the positive charged rays, and their substance of them aren't protons, but they're nuclei. Nucleuses are net positive because they have twice as many protons in them as electrons. If you really just count the electrons and protons and just ignore the word neutron.
They were more like a steady stream of particles, and radium spat out these particles like a machine gun that never ran out of bullets. Rutherford set his students a simple enough task. Use the radium gun, shoot the alpha radioactivity at the gold leaf, and with the phosphorescent plate, count the number of particles that come out the other side. In practice, that meant...
Alright, so this was the simpler experiment, sorry. So they're just shooting the big helium nucleuses into the gold leaf. And, all right, well, I haven't finished the story. It's just a story, of course, but whatever.
Sitting alone in the dark and counting tiny, almost invisible flashes on the phosphorescent screen. It was deeply tedious, but Rutherford insisted that they keep at it.
Well, it can't be deeply tedious if the fact is they're coming at a regular rate, you know, and so it can't be that bad.
Weeks passed, and the team of researchers found nothing unusual. The alpha particles seemed to punch through the gold almost as though it wasn't there. Very occasionally, they would swerve slightly as they went through.
So he shouldn't say they would swerve slightly, because that's not what they saw. They saw them deflected and landing in a different location. So it's not about swerving. It's about the fact that they came out at a different place. So why would, you know, even using the word swerve, you know, when, you know, that's, they just want to play with language. But the fact is it probably was traveling a dead straight line, because there's no magnetic field. There's nothing that's going to change its direction. So it was deflected by something in the gold leaf. It hit something and got deflected.
Hardly front-page news. Now comes what must be the most consequential off-the-cuff remark in the history of science.
So this was almost ridiculous, right? You're doing this experiment for what unknown reason, okay? You know, just to see if there's a pattern. Let's just say there wasn't much of a pattern, okay? You'd have some deflections, but there was all just scatter. All right. And then you decide to see if there's anything coming back the other way. Now, thinking that some of these things could possibly reflect off of a shiny gold leaf isn't exactly bizarre, right? It might occur to you. I mean, we already know that, you know, light will deflect off the surface of a piece of glass. You know, we're supposed to have a beam splitter to be able to do this, but no, a plain piece of glass will, you know, reflect a good deal of light if you have it at the right angle. So we already know that. So why wouldn't we expect some blowback?
One that changed the world. The story goes that Rutherford bumped into his assistant Geiger in the corridor outside the lab. Geiger reported that so far they'd seen nothing unusual. Now in response, Rutherford could have easily just nodded and walked on, but he didn't. He later claimed that he said what he said at the time for the sheer hell of it. But I don't believe him. Rutherford had great scientific...
I don't believe him. Well, maybe you should not believe him about other things than the silly little story, but whatever.
Intuition, and I think he had a hunch that something was about to happen.
Well, I don't think so. I think he just did what any experimentalist would do and say, well, let's try changing the variables. So that's not surprising. You know, I mean, you know, if you successfully pull a rabbit out of a hat, right, and you're trying to figure out, well, where did the rabbit come from? Right? Oh, you could look at the bottom of the hat and say, okay, that's where it must come out. But then maybe somebody has hidden it in the brim or something. So you start looking at other places if that isn't going to work. You tear the hat to pieces, you know, because you're going to find out where the fucking rabbit was.
Here's what he said to Geiger. Tell young Marsden to go back and see if he can detect any alpha particles on the same side of the gold leaf as the radium source. In other words, see if any alpha particles are bouncing back. Now, it's an extraordinary suggestion from Rutherford and one...
So it's really not that extraordinary, right? I mean, the idea that something might be reflecting is hardly an extraordinary surmise. So it's just, again, it's all this build-up and exaggeration about something that just seems, well, of course, you know, why not test that? So, and this is in the context, right? So, you know, physics knows about this two-slit pattern, and they've never taken photographic plates and put them perpendicular to the slits to see if there's any pattern, any photons at all ever go, you know, 90 degrees or 0 degrees, however you want to look at it, sideways. And they should if it's a wave, okay? If the thing is being controlled by waves, there should be some photons that de-entangle, okay, at those other angles. And so if they would do, they haven't done that experiment. So, you know, it's pretty pathetic.
That he had no logical reason to make. After all, Geiger and Marsden had spent weeks...
Well, I mean, why wouldn't, like I said, of course there's logic to it. If some of them are getting deflected, then you could imagine that some might be deflected back, you know, that you could get a reflection.
Seeing the alpha particles do nothing but stream straight through the gold...
You just told us how they swerved, so again, you know, just more bullshit.
...leaf, almost as though it wasn't there. Why would any bounce back? But Geiger and Marsden were young and in awe of the big New Zealander. They did their master's bidding and went back into their dark lab and watched patiently. For days, they saw absolutely nothing.
So this is the part that doesn't make, there's like a continuity to the story, because, they're saying it's 1 in 8,000. Well, it really shouldn't take days, right, to get to 8,000.
They strained their eyes to the point of myopia, but didn't see a single alpha particle bouncing back off the gold. It seemed that Rutherford's suggestion really was a stupid one. But then, the impossible happened.
Impossible. Why would you say the impossible happened? They're sitting here looking for it. I guess it's not impossible, or they wouldn't be looking for it. Yeah, that's probably enough. I think I made an error in when I paused, so we'll have to see about that. But anyway, till the next time, part 2 and such, blah, blah, blah. Blah, blah.